Dear students, now we are going to learn about decomposition and aggregation of the rules, okay, inferences. So what is meant by decomposition? So a compound rule is a collection of simple rules combined together. So when we are using any tautology, we have seen in the last session. So what we are doing, we are just combining many rules, okay. So for example, if I'm taking one inference, if I'm taking any inference, how I'll write, suppose if I take A intersection B, okay. So this is one rule and I'm combining or I'm writing the implication with B intersection C or anything. Okay, you can write it. So this will be completely one complex equation. So 1 second, how I can go for the decomposition of this one. So what I'll do, I'll take this A intersection B as one rule. Okay, again B intersection C as one rule. So I will again add these two rules in order to get the complete result. So this particular division, okay, dividing the, like you are dividing the complete rule into sub or sub rules, okay, or you can call it as simple rules. So this process is called as, whole process can be named as decomposition. Okay, so this is called as decomposition, and how we are going to do this decomposition, we'll see. 1 second. Yeah. So any compound statement or any compound rule, what we are doing here, we are dividing into simple canonical forms. So these rules are generally based on natural language representation or according to your requirements. Okay. Now, next. So the decomposition is a process where we are going to divide into multiple canonical simple rules. Okay. So this can be done in one way with the help of multiple conjunctive form. So where, see here. So this is your multiple conjunctive forms. So you have the multiple values over here. So we are dividing into simple AM equal to intersection of all the values. Okay. So this can be again, intersection means what you will get, minimum. So we have learned whenever you are having an intersection, you have to calculate the minimum of all those things. So this is multiple conjunctive antecedents. So in your given antecedent, if you have multiple conjunctives, what you are going to do, multiple antecedents, we are splitting into canonical, simple canonical forms like A1, A2 and A2 separately, then we'll go for the intersection. So this intersection will comes under your multiple and conjunctive antecedents. Okay. So first form is multiple conjunctive antecedents formula, where we are composing the complete one into conjunctive forms. Next one, multiple disjunctive antecedents. So if you have multiple things, as we have seen over here, so you'll have this one. So whenever you're talking about the disjunctive, we know that it is OR operator. So first you will divide A1, A2, so on, AN into all the separate, and then you will calculate all the things, and then you'll go for the union of all the values. So this union will be found out with the help of the max operation. Okay. So remember, whenever you're talking about intersection, you have to always calculate the minimum. And whenever you're talking about the disjunctive, that is union, will be max. Okay. So this is your decomposition second type. Third one is conditional statements. So if you have the multiple conditional statements, so what we are going to do, we are going to split up with the help of the OR operators. So one decomposed into C. This example, if you see this one, if A then B, or if not A then B2, if A then B1 unless A2. So what I'm doing here, so this is same as it is OR. If A, A2, then not B1. If A1, then B1, else if A2, then B2. So previously we don't have here if. Okay, if you see here, we don't have this simple canonical form. Here also no if was there. Okay, so then is replaced with again else with unless. In place of unless, we are replacing with if. So what exactly you are doing? You are making the complete split up of the rules according to the if else. So this is conditional if else with unless. So with else with unless. So if unless is there, we are replacing with the else part. So this you have to do according to your requirement. Okay, one more example here. It is if A1 then B1, or if not A1 and N, and if A2 then B2. So only thing is, in place of unless you have to mention then and else, then or else. Next one is if nested if then rules. So this nested if then rules also can be composed into simple one. So you can use the if then nested if else also. Okay, so this is related to your conjunctive. So when we go for the disjunctive part, 1 second, I want to show one example over here. So what we have done in the conjunctive, suppose if you have A1, 1 second. Yeah. So if you have, okay, A1, A2, A3 are there. So what you will do, I'll calculate individually A1, A2, A3. Then if you are going for conjunctive, so you'll go for the intersection. So what is intersection? Again, A1 intersection A2 intersection A3. How you calculate the intersection part? Always intersection will be minimum of all these values. So this is minimum. When I go for the disjunctive part, same thing. So I'll go for the union. So I'll split up everything A1 union, A2 union, A3. So what I'll get? Max. Okay. And third one is if else. So how you are representing if else? Okay. So you are replacing unless with else or then. Okay. You are replacing unless with else or then. And then finally you are concluding the conclusion. So whatever the conclusion you want to get, you are calculating the conclusion. So this is your overall summary of decomposition. Now coming to the aggregation. So what is aggregation? By the name itself, after calculating all the separate simple canonical forms, you have to add them, aggregate them. So this is aggregation. Same system of conjunctive system of rules, where you'll have the individual rules which have to be combined. So again, conjunctive, you'll go for the intersection part. Again, you will use the minimum. Okay. So same thing. There you will do the decomposition. Coming to the aggregation, you will go for the combining all those things. So this is your conjunctive system of rules. Okay. One second. Yeah. Next. Disjunctive same. You'll have the separate Y1, Y2, Y3 rules will be there. So it is already in the decomposed format. Okay, what you will do? You will union them. All the individual rules, contribution determines aggregated with the help of the or implies again union. And how you calculate the union? With the help of the max. So this is second one, destructive system, set of system of rules, where you will go for the maximum of all the values. So this is aggregation. Done. So finally, what you have learned, decomposition and aggregation. In the decomposition, we'll divide the compound statements into multiple simple canonical rules. And in case of the aggregation, you are combining the simple rules into one compound rule. So this is the thing for the both decomposition and aggregation. Okay. Thank you.